Welcome back, students. Today we're going to continue working with our rational expressions, and we're going to learn a new strategy for how to simplify. So far our only strategy with simplifying rational expressions, so a fraction expression, has been to factor it and see which factors cancel. So for example, if we have y squared minus 2y minus 15 divided by the binomial y minus 5, right now a trinomial can't simplify with a binomial, so we'd have to factor on top and bottom and see if any factors cancel out. So in the numerator, it's in order. There is no GCF. There are 1, 2, 3 terms, so we do our A, B, C's. So we would ask ourselves, what's going to multiply to give me 1 times negative 15? What two numbers multiply to negative 15 and combine to the middle term, which is negative 2? So those would be the numbers negative 5 and positive 3. And hopefully by now you realize, since the leading coefficient is just a 1, we can go ahead and make our two binomials, because y times y is what's going to give us y squared, and then the two numbers are just going to be the second terms of our binomials. So that's going to be a negative 5 and a positive 3, and then you can always double check by multiplying it out. Y times y is y squared, y times 3 is 3y, minus 5y combines to negative 2y, and then negative 5 times 3 is negative 15. So we'd factor the numerator, we'd try to factor the denominator, but the denominator is not factorable. But because we have this binomial, y minus 5 on bottom, we also have the exact same binomial on top. Those would cancel out, and we get that our answer is y plus 3. All right, well, have you ever considered the case of what happens if nothing factors? Okay, is that it? Is factoring our only way that we can work on simplifying these rational expressions? Well, the answer is no. And so today we're going to take a look at long division. So before we start doing long division with our polynomials, let's remember how long division with numbers works. So here we have 1,345, and we are dividing that by 5. So doing long division, what we're trying to do first is we're trying to figure out 5 times what gives us 1. Well, that's not going to work. So then we move on to the next number, and we add the 3 with it, and we ask ourselves 5 times what gives us 13. So nothing, okay, 5 times, there's no integer value that gives us exactly 5, that gives us exactly 13. But what we can do is we can get close to it. So we ask ourselves 5 times what is going to give us 13, or as close to 13 as possible without going over. So the answer to that is 2. And so above the 3, we'd put the 2. And then we'd multiply. 2 times 5 gives us 10. And then we figure out, well, how far off was that? So 13 minus 10 would give us a remainder of 3. And obviously 5 doesn't go into 3. So then you bring down the next number, that's a 4. And then you ask yourself the same question. 5 times what gives you 34? Or 5 times what gets you as close to 34 as possible without going over? And the answer to that is 6. So we take 6 times 5, and that would give us 30. Okay, so how far apart are those? So 34 minus 30 would give us 4. And then we bring down the last number, which is a 5. 5 times what gives us 45 without going over? And in this case, it's 9 exactly. So 9 times 5 gives us 45. So then when you subtract, we get 0, which means that 5 goes into, it's a factor of 1,345. If we were to take 269 and multiply that by 5, we're going to get 9 times 5 is 5, carry the 4. 6 times 5 is 30, plus the 4 gives us 34, so then we carry the 3. 2 times 5 is 10, plus 3 more gives us 1,345, which is what we were originally taking and dividing by 5. Okay. Let's look at one more example of long division with numbers. In this case, we had a remainder of 0. In this case, we're going to see that we're going to come up with a remainder. We're going to talk about what that remainder actually means. All right, so you start off 11 goes into 1. No, that's not possible. So 11 into 10. No, that's not possible. So then you go one more. 11 times what gives you 102, or as close to 102 as possible without going over? And the answer to that would be 9. So 9 times 11 is 99. And then you take 102 minus 99, which if you need to borrow from the 10, you can, and then give you a 12. 12 minus 9 is going to give you 3. And then 9 minus 9 would give you 0. All right, so 99 is 3 away from the 102. Okay, 11 goes into 3 how many times? That's not possible, so then you bring down the next number, which is an 8. 11 times what gives you 38, or as close as possible without going over, and that's 3. So 3 times 11 gives you 33, and then those are 5 apart. And then you bring down the 7. 11 goes into 57 how many times without going over? The answer to that is 5. So 5 times 11 is going to give me 55, and we have a remainder here of 2. So if we wanted to go into the decimals, we could go into the decimals, or what we could do here, this is our remainder, we could write our remainder as a fraction, and this is going to be the mixed number of 935 and 2/11. All right, so here's the integer number, here's the fraction part. We take the remainder, write it over what we were dividing by, and this would give us our answer. And then just like when we had a nice integer value, we can also check to see if this works. So what we would do is we would take 935, we'd multiply that by 11. That's going to give me 5, that's going to give me 3, that's going to give me 9. And now I'm going to multiply by this 1, and I'm going to get 5, and I'm going to get 3, and then I'm going to get 9. We add those together, that's 5, that's 8, that's 12, carry the 1, that's 10. So this is 10,285, but my original number was 10,287. All right, so when I took 935 times 11, I was really close, but I'm two apart. Okay, and that remainder, 2, now comes into play. So once you multiply, then you add in the remainder, and then that's going to give you the original dividend, what was originally underneath that division symbol. All right, so that's how long division works. Okay, just as a reminder of how it works, because it's not going to be really any different now that we're going to start working with polynomials. So I'm going to stop this video here, and if you need it, the next video is going to be working with dividing polynomials.